Bismillahirrahmanirrahim. My name is Zubair Hussain and I'm here to present my video of statistics. The topic that I have selected, these are: number 1 is introduction, number 2 is data condensation, and number 3 is data condensation and presentation. Number 4 sets, number 5 probability distribution. So first of all, I'm present my first topic, introduction. What is the statistics? A collection of methods for planning experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. Key takeaways: statistics studies methodologies to gather, review, analyze, and draw conclusions from data. There are many different types of statistics pertaining to which situation you need to analyze. And third key is statistics are used to make better informed business decisions. There are top 10 uses of statistics in our day-to-day life, and the chart is here, you can see. Now descriptive versus inferential statistics. So what is descriptive statistics? Descriptive statistics is the term given to the analysis of data that helps describe, show, or summarize data in a meaningful way, such that, for example, patterns might emerge from the data. Descriptive statistics do not, however, allow us to make conclusions beyond the data we have analyzed or reach conclusions regarding any hypothesis we might have made. They are simply a way to describe our data. Descriptive statistics are very important because if we simply present our data, our raw data, it would be hard to visualize what the simple data was showing, especially if there was a lot of it. Descriptive statistics therefore enables us to present the data in a more meaningful way, which allows simpler interpretation of the data. For example, if we had the results of 100 pieces of students' coursework, we may be interested in the overall performance of those students. We would also be interested in the distribution or spread of the marks. Descriptive statistics allow us to do this. How to properly describe data through statistics and graph in an important topic and discussed in other layered statistics guides. Typically, there are two general types of statistics that are used to describe data. Number 1, measure of central tendency. Number 2, measure of spread. When we use descriptive statistics, it is useful to summarize our group of data using a combination of tabulated description, for example tables, graphical description, for example graphs and charts, and statistical commentary, a discussion of the results. Inferential statistics. Inferential statistics are techniques that allow us to use these samples to make a generalization about the populations from which the samples were drawn. It is therefore important that the sample accurately represents the population. The process of achieving this is called sampling. Sampling strategies are used in detail in the section sampling strategy on our site. Inferential statistics arise out of the fact that sampling naturally incurs sampling error, and thus a sample is not expected to perfectly represent the population. The methods of inferential statistics are: number 1 is the estimation of parameter, and number 2, testing of a statistical hypothesis. Application of statistics. Number 1, research, interpretations, and conclusions. And number 2, meta analysis of literature reviews. And number 3, clinical trial design. Number 4, designing surveys. Number 5, epidemiological studies. Number 6, statistical modeling. Data. So what is data? Data are the characters characteristic or information, usually numerical data collected through observation. In a more technical sense, data are a set of values of qualitative or quantitative variables about one or more persons or object, while a datum is a single value of a single variable. Array. An array is an arrangement of numbers or symbols in rows and columns. In statistics, it is a group of numbers in rows and columns, with the smallest at the beginning and the rest in order of size up to the largest at the end. Frequency distribution. So what is frequency distribution? In statistics, a frequency distribution is a list, table or graph that displays the frequency of various outcomes in a sample. Each entry in the table contains the frequency or count of the occurrences of values within a particular group or interval. Frequency distribution. There is a table of a frequency distribution table. You can see relative frequency. So what is relative frequency? A relative frequency distribution shows the proportion of the total number of observation associated with the each value or class of values, and is related to a probability distribution, which is extensively used in statistics. There is the table of relative frequency. Cumulative frequency distribution. Technically, a cumulative frequency distribution is the sum of the class and all classes below it in a frequency distribution. All that means is you are adding up a value and all of the values that came before it. Here is a sample or example. You get paid $250 for a week of work. The second week you get paid $300, and the third week $350. Your cumulative amount for week 2 is a $550. $300 for week 2 and $250 for week 1. Your cumulative amount for week 3 is a $900. $350 for week and week 3, and $300 for week 2, and $250 for week 1. Graphical representation. Graphical representation refers to the use of charts and graphs to visually display, analyze, clarify, and interpret numerical data functions and other quantitative structures. Graphical representation. Graphical representation can be done in many graphical presentations like pie chart, frequency bar chart, frequency histogram, frequency polygon or GIF chart. Sets. Now that sets, basic sets and subsets. Operation on sets. Sets are well determined collections that are completely characterized by their elements. We say that A is a subset of B, written as A is a greater less than or equal B, or A is a less than equal of B. If every element of A is an element of B, thus A is equal to B. If and only if say number second, representation of sets. Types of sets. There are many types of sets: empty or null set, finite set, infinite set, equal set, unequal set, and equivalent set, and singleton set, universal set. Now we go on subset. So what is subset? For two sets A and B, every element of A is also an element of B. Proper set, subset, and proper subset. probability distribution. Probability distribution is the measure of the likelihood that an event will occur in a random experiment. Probability is quantified as a number between 0 and 1, where loosely speaking 0 indicates impossibility and 1 indicates certainty. The higher the probability of an event, the more likely is that the event will occur. Suppose you draw a random sample and measure the heights of the subjects. As you measure heights, you can create a distribution of heights. This type of distribution is useful when you need to know which outcomes are most likely, the spread of potential values and the likelihood of different results. The end.
Hey, masyarakat juga ada kebar. Kalau
Product bigta jitai.
Itu क्या ना
18 मिनट टाइम था